Hello everyone. Today we are solving this problem valid parenthesis. And in this problem we are given an input string which consists of 6 characters. These characters are opening brackets and closing brackets of these types, and we are required to find if the given string is valid or not. And to see if the input string is valid, if open brackets must be closed by the same type of brackets. It means that if we have an opening curly bracket, then it must be closed by a closing curly bracket, and similarly for this bracket and this bracket as well. Second condition says that open brackets must be closed in correct order. Now what is the meaning of correct order? Suppose we have this string. Well, correct order simply means that those characters or brackets that are inside other brackets needs to be closed first. For example, in this case, these are the brackets which are outside, so yes, this opening bracket is closed first. Then we come to this bracket and then another opening bracket. But now what is the bracket which is the nested? Well, these brackets are nested and therefore this bracket needs to be closed first, and yes, it happens here, and then finally we close this bracket. So correct order means what we might have studied over the years when we did maths and algebra. So those brackets which are inside needs to be closed first, and then we come one step outside and so on. This means that if we have this square bracket and then this opening bracket and another square bracket and then this opening bracket, then this is not valid. The reason is that this opening bracket is inside some another bracket and therefore this needs to be closed first. So this is the meaning of correct order. So now let us see the solution for this problem. So I have already given you a hint to solve this problem. When I say that those symbols which are nested inside needs to be closed first, and this is the meaning of correct order. So those elements or those brackets that are nested inside, we can see them that these brackets are actually appearing later. That is, this character has appeared after the occurrence of this opening bracket and this one has occurred after the occurrence of this opening bracket. So this opening bracket which appeared earliest will be closed in the last. And doesn't this ring a bell? Now can you think of a solution? And when I'm saying in the last, that doesn't mean that at the last of the whole string, because these are some characters which are going to be passed or checked after this one, but because these are not nested inside this sequence or these characters. So now can you think of a solution to solve this problem? So pause the video and think of it. Well, the data structure which we are talking about here is a stack, because a stack is something which works on the principle of LIFO, that is last in first out, and this one is the last bracket in a sense, the last opening bracket maybe in this particular part of the string, and therefore this is the one which needs to be out the earliest possible. So let us start by actually parsing this string and let us see what happens. So initially I'm at this opening bracket and I don't know what to do with this. So I'll just write this one. And I know that there is a possibility that some closing bracket which is associated to this opening bracket might appear somewhere later in the given string. Then I move to the right, which has this opening curly bracket. Now definitely I can assume there is a possibility that this opening bracket will be closed as well by some another curly closing bracket. So I'll store this opening bracket as it is. Again we move forward and following the same principle, we write this opening bracket. Okay, everything is fine till now. Again I move forward and now this time I see that there is a closing bracket. And I know if there is a closing bracket, then for this closing bracket to be closed, it needs to have an opening square bracket exactly, and that opening square bracket needs to be on the left. So I can see this is actually on the top or on the frontmost part of this parse structure. So rather than actually writing this here, rather than storing this here, what I can do is to remove this opening bracket from this structure, and then I'll move forward again. So I move to this closing bracket and again the same thing happens. I see that there is also an opening bracket which can be associated with this closing bracket, and this is the reason that I'm going to remove this opening bracket as well. Again I move forward and I again see a closing bracket. Again I can see that this closing bracket can be associated with this opening bracket, and therefore from my structure I can remove this as well. Again we move forward and we see that we have another closing bracket. So this needs to have some opening bracket on its left, but since we have nothing here, we can say this, that we are actually not opening this particular bracket, and it means that this structure is wrong. So when we have nothing in our structure and we encounter a closing bracket, we can always say that the given string is not valid. So definitely the answer for this string is going to be false. That is, this is not a valid string, and therefore there is no point in actually passing any further because this is wrong. Suppose that we didn't had this closing bracket, then the one we would have moved to is this opening bracket. Then as we had nothing in our structure and this is an opening bracket, so we need to store this because we have this possibility that some closing bracket might appear later. So we write this as it is, and again we encounter a closing bracket when we move forward, and therefore the top or the latest symbol which is in our structure is this opening bracket, which can definitely be associated with this closing bracket, and therefore we make this structure empty and we are fine. Finally we can say that this string is valid, so we return true. So this is the logic to solve this problem. So basically what we are doing is, whenever we encounter an opening bracket, we store it in our structure, and whenever we encounter a closing bracket, we see if the opening counterpart of this current bracket is the latest element or not, and if it is, that is the last element, not the latest. In that case we are going to remove that particular opening bracket. Now, there could be a question in your mind which is very general. Suppose we have this kind of a string, then what? What would happen? Let us also see this. I come to this one, I write it, again another opening bracket, I write it, then a closing bracket. And see, as per what I've told you, we are definitely going to return false, but we could have stored it inside this stack or whatever structure we have in the hope of thinking that this string might be true. But as you can see, as I have told, that those characters which are actually appearing in the last, that is for example this one, needs to be closed first, and therefore we can always say this, that is the intuition behind this, that if we have a symbol which is closing, then its opening symbol must be the top element or the last element of our string, and if that is not the case, then the string is always false. And definitely there could be times when we have strings like these, then definitely we store this opening bracket, then closing bracket comes and therefore we remove this, again an opening bracket comes and we store this, another closing bracket comes and we remove this. So that's completely fine. At the end we should have an empty structure, and if there is any irregularity as we have discussed here, then we must return false, or if the structure is not empty, then also we must return false. So this was the solution to this problem, and I hope that you will be able to solve this question now. And now it's time to code the solution. So let us start by actually having an integer whose value is equal to the size of the given string. Next we need a stack which will store characters. Therefore a stack to store characters, let us call this stack st, and then we'll pass the given string. Now what are the possibilities we have? We could either have an opening bracket or a closing bracket. Now if we have any opening bracket, what we are doing is putting it on the top or on the front of our structure. Let us say on the top because we are talking in terms of stack. So if current element of string is equal to this or this, in that case I am going to push it inside our stack, whatever is the current element. Else if we have a closing bracket of this kind, and on the top, in this case what we need is an opening bracket of the same kind, that is this thing. In that case everything is fine. All I am going to do is to remove this opening bracket from our stack, and therefore I'll pop this. Otherwise if I have a closing curly bracket, then I need a curly opening bracket, or if I have a closing square bracket, in that case I need an opening square bracket. Now if any of these conditions are not satisfied, that means that there is something wrong in the given string, that is it is not valid, and therefore we can say that else return false. Finally, when we have done these operations, all we are required to check is whether the given stack or our stack is empty or not, because there could be times when all we are given are only opening brackets, and in that case our stack won't be empty because we want every opening bracket to have an associated closing bracket, and therefore if our stack is empty, in that case everything is fine and I can return true, But if this is not the case, then I need to return false. So we are done with the solution, but there is one small problem. Suppose if the first character that we encounter is a closing bracket, and it means that currently we have no opening bracket in our stack, and in this case, this statement will actually cause an error. Or maybe this one or this one. So before doing this, we need to make sure that stack is not empty. And for that, we need these statements as well. That is, we are checking that stack is not empty. And if it's not, only then we are going to check for a closing bracket. So let us run the solution, accept it, submit, accept it. So this is the solution for this problem, and the time complexity of this solution is just order of n, because all that we are doing is parsing the given string only once. So that's it for the solution, and I'll see you in the next video. Thank you.